Okay, so today we are going to continue with what we had looked at um, last Thursday, and we're still talking about the unit circle. So I want to remind us a little bit about the unit circle. Another thing, have you guys seen this before? The different quadrants, quadrant 1, 2, 3, and 4. You seen that? And it's related to how the angles open. Remember, our initial side is always here. That's our initial side. And it rotates, right? It rotates around the origin. So if my angle was right here, like pi over 3 or so, that would be in the first quadrant because the point would be right here. Here would be my terminal edge, and we would have a point on the circle that's in the first quadrant. Okay. So the important thing for today is that the unit circle has a radius of 1. Remember that. That's the main thing. Everything comes from the radius being 1. We're going to go pretty far into trigonometry starting next week. So we want to be really familiar with how the unit circle works. And the reason why it's such like if you were stranded on a desert island, you're really bored. You're like, I'm going to figure out what trigonometry is. You could figure it out from a circle that has a radius of 1. It's a really kind of like special situation where you could literally, draw in the sand and figure out all of trigonometry if you have a circle with a radius of 1. It's crazy. Okay. And so you can always make a right triangle with a hypotenuse of 1. So remember, just hypotenuse is across from the right angle, across from the right angle. And you see anywhere I rotate this red, this red line segment around, as I rotate it around, it doesn't matter where it is. It could be down here on this side, and we would still end up with a radius of 1. Okay, so just keep in mind that the unit circle, since it has a radius of 1, if I rotated around the circle and I ended up with, way over here, it doesn't matter. That's 1, that's 1, that's 1. It's like spokes of a wheel. You don't have a wheel with different length spokes. Otherwise, I don't know what kind of bike that is. It's broken. That's a broken bike. Don't even try to drive it, ride it. So look, if we have a radius of 1, right? It's a unit circle. And look at the triangles that are going to be created. I can put another triangle over here. If my angle measurement opened all the way over here, right? I could then drop my side of the triangle there. It's still going to be a radius of 1, right? It's still going to be a radius of 1. And essentially, what I'm interested in is the triangle that we just made right now. They are related to our special angles. Okay. Now, the special angles are these, and this is one thing I asked for you to do in the homework. I asked for you to find the coordinates for each of these. So a 30-degree opening, if it opens up 30 degrees, right, it is also opening up pi over 6 radians. Because we have a unit circle, a length of 1 for the radius, all the way around is 2 pi. Halfway around is pi, as I've been mentioning. So I had you find the coordinates, right? The coordinates for each of these. I had you find the coordinates. You had to find these. And I told you the trig kind of shortcut, but today we're going to learn using triangles. And trig is just the math of triangles. Trig, try. Okay, so keep in mind, these are special angles, pi over 6, pi over 4, pi over 3. And they seem like there's quite a few of them to memorize, but there's a pattern to it. Okay, there's a pattern to it. And today what we're trying to use we're using special triangles to figure out all of the coordinates all the way around. By the end of the day, we're going to feel pretty good about that. So, special angles. Special angles. These special angles are the ones I just showed. They're theta values that create these 3 special right triangles. Okay. These special right triangles are going to fit, and I'll show you because I have a good exercise next. They're going to fit into the unit circle in very specific places. And where they fit creates and tells you what the coordinate is going to be. Okay. So basically, the game we're going to play next is, which triangle would fit into a certain position. It's kind of like, like the anagram where you have all these different shapes and you could put them all together to make like different other shapes. Maybe you've used that before. I don't know if it's called anagram actually, but I want to teach this spatially, where you see it based on the shape and location of different shapes. Okay, so let's look. We have this one right here. It has a radius of 1. So the sides are the same. This one is where we have a 45. Go ahead and add these numbers. 45, 45, 90 triangle. Okay. Maybe you've seen that before. And maybe we need to even label that. Let's label this 40. Let's do a different color. 45, 45, 90. I don't need you to, I'm not going to go into this specific topic that you've seen before too far, but I want you to know that these measurements always work. When the radius is 1, this side will always be root 2 over 2. This side will be root 2 over 2. Because essentially, these angles are congruent. They're the same measurement. So the sides across from them also have to be the same. All right, guys. This one right here is 30 degrees. This is 60 degrees, and that's 90 degrees, right? So this one is a 30, 60, 90. You're like, man, there's one more, but what do we see in this last one here? The same side lengths, right? You see the same side lengths? That's because now we've just kind of rotated it. Now that's 30, now that's 60, that's 90. So this again is our 30, 60, 90. It's just rotated or flipped, right? It's flipped around. All right. So the main thing here is this is connected to our 5 best friends. Because every single coordinate with these special angles, the special angles where we can fit these 3 triangles, okay, no problem, Brian. These 3 triangles into our unit circle, the coordinates are always going to end up being 0, 1/2, root 2 over 2, root 3 over 2, and 1. These in the middle, these 3, it's going to be either plus or minus. But the main thing here is to keep in mind that the special angles are created with these 3 special right triangles. And you could see here, our 5 best friends that are always going to be our coordinates along the unit circle, they're components of each triangle. Look, 1, 1, root 2 over 2, root 2 over 2. Okay. 1, 1/2, root 3 over 2. 1, root 3 over 2, 1/2. Okay. So now I want you to look at this with me. I want you to look at this. Because this is our unit circle. The only thing I've done is cover up the coordinates. And actually, we're going to zoom in on the top half to start. All right. So look at my 3 triangles. Look at my 3 triangles. Because these are our special angles, right? They're 30 degrees, 60, 90, 120, 150, 180, 0, 45, 90, 135, 180. Those are the degree measurements, and then our radians are on the outside. So let's look to see what coordinates are already listed. Because it's a unit circle, this is one measurement. So at 0 or all the way around at 2 pi, the coordinate is 1, 0. Okay. Up here, it's 0 for x, 1 for y. Down here, it's -1 for x, 0 for y. Down here, it is 0 for x, -1 for y. So you can see we had our 5 best friends here. The 0 and the 1 only really ever come into play when you're at these 90-degree parts or these pi over 2 increments. Okay, so let's see. The name of the game is Name That Triangle. We'll go ahead and call this Triangle 1, Triangle 2, Triangle 3. All right. So if I wanted to fit a triangle right here, where it rotated open to pi over 6, which triangle should I put into that position where the corner will be here and this is the other side? So which triangle will fit into that position? Number 1, number 2, or number 3? Number 1, number 2, or number 3? Good, Josh. Good, Dave. Good, Alicia. It's that easy to just look and see which triangle fits. Anyone else want to take a guess? We got 1, 2, or 3. Which one will fit right here? Which one will fit right here? All right, let me show you. Number 2 is the winner. Watch what happens. Watch what happens. Put it right there. Right? That's it's not perfect. Let's do it like that. Okay. You see the triangle fits perfectly right there? Because it's one of our 3 special triangles, the 3 special triangles are what make the special angles. So this is where it all comes together. Remember that this point right here has an x and a y value. So when you have a unit circle, this is always 1. The red is always going to be 1 because that's the radius. But if I wanted to put the x value here, what do you think the x value is going to be? This side of the triangle is √3/2. This side of the triangle is 1/2. So what is the x value going to be of that? Remember, it's one of our 5 best friends. What do you think? I need one person to take a wild guess. Even if it's a wild guess, I won't call you out. What is the x value going to be? Good, Alicia. Good. Now look to see what we're doing here. Essentially, remember, the x value, right? This is a point. This is a point, right? The x value is how far over you go along the x-axis. The x value of this point right here is related to this triangle. Because look, if I go over this far, how far over have I gone? I've gone √3/2. The length of the triangle, you see how it's aligned with where that point is? So watch. The first, let's take our guess. The x value is √3/2, one of our best friends. What is the x value? Everybody take a guess on this. What is the x value to get to this point? Excuse me. What is the y value to get to this point? That is going from the origin. How far up do I need to go to get to that point? It's all based on the triangles. Good, Alicia. Anyone else? Alicia knows. I need some others. Good, Hunter. Good, Dave. The side of the triangle is 1/2. So since the y value is from the origin, how far up you need to go, you go up 1/2. Let's see if we were right. Oh, well, we were right. Do you see how the triangle, the special triangle, fits into that position? And it tells us what the coordinate is going to be. All right, let's keep going. Okay, we got our triangles here. Whoops. Okay. Dang it. All right, how about let's take another one. How about root or pi over 3? Pi over 3. So I rotate over pi over 3 right here. So we have this is 1 for my radius. But which one of my triangles is going to fit? Not all of this, not the piece of the pi, but the triangle, right? That's going to fit right in this little space. Which one should I choose? 1, 2, or 3? Good, Alicia. 1, 2, or 3 to get all the way over here to pi over 3. What do you think? 3. Good, Dave. All right, guys, we got it. Watch what happens. Right there. You see? We can always make a triangle that has a radius of 1 that connects from the origin to the point on the circle. And this tells us what that coordinate is going to be because they're the exact same triangles we're always using. And we are always going to have these special angles are always going to have coordinates with values of 0, plus or minus half, plus or minus √2, plus or minus √3, and 1. So you only have 5 things to really remember because you can, hopefully by the end of this, visualize what the coordinate is based on this triangle that's created. So look, the x value, how far over do we go to get right below this point. We go 1/2. Right? We go 1/2. How far up do I go to get to that point? It's the side of the triangle. √3/2. And let's see if we were right about this. Oh yeah, you're right. All right. So this is a matter of looking to see, well, we got 3 triangles to work with. Which triangle do I choose? Okay, so we've done root pi over 6, pi over 3. How about this pi over 4? If I rotate over from the initial side, I rotate over to here. What triangle are we going to use? Remember, this is always the radius of 1. So which triangle is going to fit in there for this one? To be pi over 4. We're doing this one now. Which triangle will fit? Whoops. Let's get them so you can see them. Which one do you think will fit there? One of the hints is it's pi over 4. It's also 45 degrees. So we can take the 45, 45, 90, take this triangle, and look what we put there. If we were in class, guys, I would have had these for you to play around with. Sorry, I'm hogging it all. I don't have these for you. So now this triangle, remember, is a 45, 45, 90. Oh, 90. And I look at this and I see that, well, that's √2/2. That's √2/2. So anytime it's at the 45 degree mark, it's always going to be one combination of this. √2/2, √2/2. Okay. So let's see. Yep, we got it. All right. Now, am I cutting in and out, guys? Is my sound okay? You guys hear me all right? Let me change that. One sec. Okay, Tavon, that might help actually. I changed my mic. I changed my mic. All right. Okay, so all we have to do to find the other coordinates for the special angles is to keep in mind that we're using these 3 triangles. So I'm going to go ahead and start working through them. This guy I wrote on the other side as well. That one fits right here. Very glitchy, huh? Okay, I'm going to stop recording. That actually is enough for the recording part. I'll go ahead and post that one. And it's usually when I record, it starts to get glitchy. Is it a little better now? I'm glitchy. All right.